Hello, good morning to everyone. I am Joy Bhattacharjee from Technocrat Institute of Technology, Bhopal. Now, today I will discuss introduction to data structure. So, what is data structure? Data structure is the physical and logical organization of any data. A data structure is a scheme for organizing data into the memory of a computer. Some of the more commonly used data structure include lists, arrays, stacks, queues, heaps, trees, and graphs. So we can further classify the data structure as linear and non-linear. Linear data structure include lists, arrays, stacks, queues, and non-linear data structure includes trees and graphs. The way in which data is organized affects the performance of the program for different tasks. So the performance is based upon the how we are organizing the data into the physical storage and how we are accessing the storage. The performance is mainly on two different aspects: space and time. Computer programmers decide which data structure to use based on the nature of the data and the process that needs to be performed on that data. And suppose we are having an example of a queue. A queue is an example of commonly and used simple data structure. A queue has beginning and end called the front and back of the rear. So we delete the element from the front of the queue and insert the element from the rear of the queue. Data enters the queue at one end and leaves at the other end. Because of this, data exists the queue in the same order in which it enters the queue, like people in a checkout line at a supermarket or people standing in a queue to take a movie ticket. These are all examples of the queue. A binary tree is another commonly used data structure. It is organized like an upside down tree. Each spot on the tree, called a node, holds an item of data along with the left pointer and a right pointer. So left pointer points to the left subtree and right pointer points to the right subtree, and every tree has a root and leaves. The pointer are lined up so that the structure forms the upside down tree with a single node at the top called the root node and branches increasing on the left and right as you go down the tree. Now we have to choose the data structure. By comparing the queue with the binary tree, you can see how the structures of the data affects what can be done efficiently with the data. A queue is a good data structure to use for strong things that need to be kept in order, such as a set of documents waiting to be printed on a network printer. This is a real life example of the queue on the computer system. The jobs will be printed in the order in which they are received. Most network print servers maintain such as print queue. A binary tree is a good data structure to use for searching sorted data. A middle item from the list is stored in the root node, which lesser item to the left and greater item to the right. A search begins at the root. The computer either finds the data or moves left or right depending on the value of which you are searching. So there are various types of trees like M search tree, binary tree, B plus tree, AVL tree. So depending upon the weight of the leaves, there is a classification of the trees. Items can be located very quickly in a tree. Telephone directory assistance information is stored in a tree, so that name and phone number can be found quickly. The real life example of tree data structure is the mobile phone address book. In mobile phone address book, we use the tree data structure. For some applications, a queue is the best data structure to use. For others, a binary tree is better. Programmers choose from among many data structures based on how the data will be used by the program. So there is an example like Alice has a two built-in data structure that can be used to organize the data or to create other data structure. List, arrays. A list is an ordered set. It is often used to store objects that are to be processed sequentially. A list can be used to create a queue also. So in this video lecture, we have dealt with the introduction of data structure, queue, and somehow or somewhat we have discussed the tree data structure. Thank you everybody.